Welcome to Stay Sharp with Razor Leaf, your secret weapon for all things digital in products and manufacturing. In this episode of Stay Sharp, hosts Jen Farello and Jonathan Scott chat with Oleg Shilovitsky about the future of digital products and manufacturing and looking forward in 2025. They dive into how graph technology and AI are transforming product lifecycle management, enabling better collaboration, real-time integration, and innovation. The discussion explores challenges in modernizing engineering workflows, generational shifts in tech adoption, and emerging trends for 2025. Let's tune in.
Welcome back, everyone, to Stay Sharp, the podcast about all things digital-related to products and manufacturing. I am Jen Farello, and I am joined today by my co-host and good friend, Jonathan Scott.
Hey, everybody.
First off, happy holidays. I'm breaking our usual rule about not noting times because our topic today is what's coming in the next year, and when else would you say that except for at the end of another year?
Fair
and
enough.
I am in a sparkly shirt, so clearly it's around the holidays.
Fair enough.
And joining us today in our look forward is a man who I can confidently say needs no introduction, which is good because even though after years of knowing him, I'm pretty sure I would still not be able to pronounce his last name. So please welcome Oleg. Oleg has done a little bit of everything in PLM. He has held roles at both Dassault Systems and Autodesk. He's founded 2 companies, worked as an independent consultant, and is probably one of the most prolific industry bloggers, certainly that I know, always with his finger on the pulse. So a natural guest for our topic today. So welcome, Oleg.
Thank you. Thank you for this kind introduction. Happy to be here and looking forward to the discussion.
Yeah, really great to have you, Oleg. I know you and I have lots of great conversations over the years, so it's fantastic to have you on the podcast and actually record one of those, and hopefully people will get a flavor of some of the crazy stuff we talk about.
Which means I've got to have my work cut out for me, kind of controlling and reining in, that sort of thing.
That's true, Jen. That is true.
I was preparing and I said, Jonathan, you're one of my top people to discuss, and I'm so happy we get it now on record. So
That's right.
All right, then. Where do you two want to start?
Well, I think the topic, right? The topic today, like you said, Jen, is we want to talk about looking forward. And I think this is a perfect topic for discussion with Oleg, right? Oleg, you write about this plenty on your blog, looking back, looking ahead, that sort of thing. So, let's talk about that. Let's talk about a couple of trends. And we prepped a little bit for this, right? Coming into it about the kinds of things we might talk about. But I think there are some things that you see in the space, I agree, I see in the space that we could talk through that maybe are going to get more real in 2025. Maybe are going to get some more traction, things that could happen. And that's the general topic. But let's dig in. Out of the couple things we talked about, let's start with maybe graph technology and AI in that sort of area. So maybe the place to begin is backing up a little bit about graph. What's graph? Why does it matter? Who's using it? That kind of thing. You want to give us a little intro there from your view of what's going on with graph technology?
Yeah, sure. It's certainly one of my favorite topics, taking me back almost 20 years ago when I got very excited to learn about semantic web technologies. But even going back, like why to talk about graphs today and why it is important. I think no one will argue that data is important. Not these days anymore.
Certainly not us.
But certainly, Jonathan, you might remember, 10, 15 years ago, the debates, we need to talk about data, we need to talk about process. Remember this?
Mm-hmm. Yeah.
So that was the conversation. Data, process is what's important. Everything runs by processes. Those were a little bit after the days when no one already asked a question why Sergey Brin is Googling and indexing the entire internet. But in the beginning, they said, why do you need to index everything? Yahoo knows where you need to go, right? Until everyone realized that there is something that Google built behind. So when I got excited about semantic web technologies, it was about how to understand relationships between different websites and different web pages and data is located. Now, if you have your mind tuned to the engineering and product development, you realize that technically the data is represented by different systems, and data is represented by different activities. It's not very much different than data is sitting on the multiple websites. But everything is different. Of course, websites are public and data is private, and data is behind different firewalls and behind different places. But that was the beginning. Now, let's bridge it to PLM. The PLM was born to manage CAD files at the beginning. Mm-hmm. But essentially, the most forward-thinking systems of all times were always placing a little bit more of data. You know, the CAD file manager was just managing files, but then we added a little bit metadata, and we got excited how we can put some information.
Yeah, look at what we can do now, right? Now.
Yeah, look how we can put some names on this Smartium object. Okay, all right. That's still some people do it somewhere, I know. So then more sophisticated and advanced data managers like metrics and then later eras came with the flexible data models. You know, we get different CATIA and Team Center related. But again, it's also about data, about how to make this data flexible. But here is the thing, but behind all of them, there is a relational database. And the PLM data was like data model on top of relational database.
Right. Yeah, we had object-oriented on top of relational. And it was just sort of, we used what we had, right?
Yes. So now two things here came as the first. What is this object model and how to make it more expressive in terms of semantics? And second, what is the most efficient and scalable mechanism for data management to put it behind? So, and that's why graphs sort of came in these two dimensions. So first of all, graph as a semantic model is much more expressive than anything else that was created even in PLM as object models. Again, they're amazingly combined and like coming together, because a graph is the best expression of relationships between topics, objects, and anything you can think about. So that's why graph as a model is very important, because it gives the best expressiveness of the information and the model of the information. It doesn't matter how we store it. We can store it in a text file, but graph model as a semantic model, it's very important now. And the second is what comes in databases. Let's make a little bit trip with some fancy names, but we'll explain them. So 20 years ago and 10 years ago, we sold systems that only can use databases that approved by IT.
Right.
So I don't know if you remember many years ago, like what database you use. What is that? Borland? What? I mean, no. Okay. If you are using SQL, what is Microsoft? Microsoft doesn't know how to do database, like DB2 or Oracle. Yeah. I mean, I'm talking like
years ago.
Years ago, yeah. But again, it was a time when IT expected the people to come and to get their approvals for using of the database infrastructure, and that's why you use what IT approved. So now, what has changed is that when we move to the cloud infrastructure, we live for the last 15 years through the Cambrian explosion of the database technologies. Why? It's because the approved by IT database may be good, but not most efficient way to manage data, and sometimes also not the most cost-effective.
Yeah. So, and not relevant because of the cloud, right? I mean, when you move to the cloud, they're out of control, so it doesn't matter.
Yeah, the moment of time, IT doesn't need to approve the cloud database, or there is a flexibility around this. Like you can put whatever you like there, and that's brought this innovation, brought the concept that called, still I don't think people are very much familiar with this term, it's polyglot persistence. Now, give another example, and everyone familiar with this example, polyglot programming. So again, 20 years ago, we've been deciding what is the best programming language to write in. It's a COBOL or Fortran or C or God forbid C#, or like all this. Or if you are writing
C++, Python, all the things.
If you're writing in Visual Basic, you're poor guys. Like how anything serious can be created using Visual Basic. So
we're dating ourselves, right? We're all really dating ourselves.
Yes, true. But wait a second. we go now. we go now with the databases, and no one is, by the way, is discussing that we can create a server in Java and write the user interface in HTML. That was okay. So now the same, and we make them interconnected and use them as we need. Now the same is happening with databases. The database stop being the kind of a single foundation of everything, and I want to put everything there. It just became a tool to store data.
Right.
And to store data can come in different modelings. I want to store documents. I need one data storage. And I want to manage relationships between items and assemblies, and I need it to be a graph or something else. So the moment it happened, combined with microservice technologies, it became just a tool that can be used as a right storage for a particular service. So that's why polyglot persistence we can use multiple databases in our system, and they will be optimized for particular specific needs. But this is something that brings the graph database as a very interesting and unique tool that's capable to do something that no one else in other databases cannot do. For example, give you an example. If I want to know what items are not used by any products or bill of materials, how you can express this query in SQL database?
Yeah, it's
You're
tough,
smiling,
right?
Yes.
Yeah, I mean, it's a join, right, against sets and big data sets to find something missing, right? Yeah.
So I will give you a link to OpenBOM blog, and you will see that this is the 2 lines in Cypher.
Right.
So why it's 2 lines in Cypher? It's because the model, its graph, and relationships is the first, the basic element, how it works.
Right.
First-class citizen. So that's why it makes a difference. So again, 2 topics. The graph as a model, which gives an expressiveness. This is important. And a graph as a database that gives you a specific type of operations and specific optimized performance. Like I can find the most connected supplier. Single graph data science, single algorithm works on graphs. Yep. Don't need all joins, all this craziness. So those are, and those 2 things that makes, in my eyes, graphs are very valuable and important in the future. And I see some recognitions on the vendors. Different vendors can be mentioned in this in this context. But now there is an icing on the cake. The same graph model is used in the large language models as a neural network for AI. So that's why
the connection with why it's going to be more important than ever then. Why it's going to be more important in 2025 is AI and the connection there.
Yes, and to say something in this context, we can think about the same that happened to databases. You probably remember some PLM vendors developed their own databases many years ago. They said, standard databases can't perform and do anything. So then obviously it was, everyone was moving forward with the industrial data. Now, what happens with the AI, the large vendors, the big players, will make technology. So I expect Google, Microsoft, or whoever else will invest enough money to make technologies the core technology. Now, what is the role of vendors that, in particular verticals like product lifecycle management, is to contextualize these models and contextualize the services for particular industry. I'll give you an example. If you now go to ChatGPT and you write there, create a bomb for electric bike, you will, by the way, get a very decent bill of materials with all components, and you can even ask what suppliers to use. for a winter electric bike, and it will give you some sense of semantic relevance for this. No, but this is not what everyone wants, right? I'm in my company that developing bikes. I want this bill of materials with my parts, with my suppliers, with my everything, right? So that's where the big innovation is coming, because I want my data contextualized with the AI technology. So that's where the whole innovation will be happening. And that's why, again, graphs are sitting in the middle of everything.
Well, one of the things I wanted to dig into about that is, when people talk about training large language models, and in this context of product development, right, you need data to train the model. And if you want your data to be used to do that, well, the question is, how good is your data? Do you even have a handle on it, right? This is one of the topics we talk about a lot with our customers about, what are you trying to do to build out your digital thread? Do you even have a handle on your data to start with? But I see this connection, and this is one of the things I wanted to chew on this possible trend, is if you start putting your product data into a graph model, is that going to make it much easier for AI in the future to interpret your data set? Because so many relationships are, already connected. They exist, like you said, as first-class citizens. So, is that part of the trend potentially, that if you're using graph to represent your data, it makes it easier for graph technologies to leverage it and use it in AI? Is that something you see, Oleg, or am I, kind of walking down the wrong path there?
I think you are absolutely on the right path, and here is why. So the graphs are self-describing. So you use the same model to describe the data and also put the data itself. So it's a model that is giving you semantics embedded in the model itself.
Right.
In different relational databases, semantics cannot be described by the data model. You have a table with predefined attributes. And yes, in some top PLM platforms that run in the industry now, if you dig inside, you will find something interesting, a table which is called attribute 1, attribute 2, attribute 3, attribute 4, attribute 155. you know them, right? So
yeah. And so on.
Yes. So, and those are billion-dollar platforms, right?
Yep.
So
and then you find table 2, attribute 1, attribute 2,
yes,
up to table 255. Anyway,
so
that's a different issue.
Seen those you probably seen most probably seen those tables. Exactly, you know what I'm talking about. So, but now, if you think about how you can make these tables moving forward with the data, and how someone can potentially learn from this, you cannot.
Right.
That's why graph expressiveness provides best foundation for different ways to bring data to AI and to what you ask about training, but also in terms of other services, being able to read this data without additional explanation. What is the attribute 164? That's a problem. Now, the best example in the industry is schema.org. So if you've heard about this, I'm sure you know, but if not, maybe for our listeners, we can bring the schema.org. It's a very interesting initiative. It was started by search vendors. Google, Microsoft, and few others. I think even Yandex was there. So they needed a mechanism that can describe the content of the web page in a uniform way that can be recognized by multiple services. The service was crawler that goes to the page. So they created these schemas that technically share it, but they are not different. Those are annotations taken in the semantic web standard. So by placing these annotations and knowing how to read them, they made it's possible to crawlers from different companies to go on the web page and understand what is there. So if you put on the web page this annotation, you know what is on the page. So my crawler knows what is on the page. Now imagine that you have a piece of content. Let's take bill of materials that contain some information, and independent reader can go there and understand what is in this information. And the entire graph and everything can be discovered and can be read. This is one of those standards that can change the way we are intercommunicate with the different systems combined in the digital thread, because I want to read this. I want to read an information from another system. I want to link between them. So it's just much more powerful model, which with a lot of capabilities that are going to change the way we think about data and the way systems are working. And the biggest expectation that I have in this space is that we are going to change the trend of adopting new technologies in the companies. So that's the biggest problem. So today, like if someone runs any of the major player system, if you come and say, well, I want some additional business implementation, it is not included. What are the options? You can say, oh, we need to replace everything. I mean, it doesn't sound good, right?
That sounds and it's costly and time-consuming.
You are spot on, Jan, because no one will take this decision because the ROI will be like in the next century. So that's that. But if we can offer technology that can come and connect all pieces of existing data in the data and process layer on top of this, companies can find a way to work with all the services together without replacing the systems of records or whatever fancy name we use to call them. But that's the mechanism that can shorten the path for someone to get this information and organize new business services.
And truthfully, I mean, AI is one of those things, right? You could think of that as one of those services. Oh, I want AI on my product data. Well, should I go find the vendor who's doing PLM today, who's got the best AI tool, and re-implement my whole stack? No. What you want to add on AI as some kind of service, whatever it is it's going to do for you, right? To look at your existing data. And to your point, Oleg, right? That's the trick, is once we start to make that data available to some other service, right? The data and process layer is exposed. That's what can change the nature of business implementations. Is that going to take us down a repeat path of the arguments about best of breed and monolithic and integrated and spaghetti code and all that?
We will come there, but wait a second. Let me finish this one thing.
You guys are killing me here. We're supposed to be talking about trends. We're on one topic. We're more than halfway through. Okay, so Jonathan, I'm dying to dig into this too.
Okay.
Sorry. Go ahead, Oleg.
If everything you have is a hammer, then everything looks like a nail, right?
Yes.
Yep.
And we always bring it in a negative context. So let me bring it positively. If any data can be represented by a graph, that anything that works with graph can work with any data. So if I have a service that's capable to read graphs coming from any system, I have a universal hammer, right?
Yeah, that's right.
That's why graphs are important.
All right, so other than your universal hammer in 2025, what else do you have in your toolbox for 2025 before we run out of time completely?
Jen, are you saying we've got to get to another topic?
I'm saying, either that or then I have to redo the intro, because we're clearly not going to be talking about trends. We're going to be talking about AI and graphs.
Or trend.
Right. One big trend. Anyway, moving on.
Okay,
what else you got in your toolbox?
So we prepped to talk about another trend, right? Potentially. And I think this was interesting too. And of course, we could connect it back to graph. Maybe we won't because we don't have enough time, but
universal hammer.
That's right. Universal.
I'm telling you.
Universal hammer. So the thing that we were talking about in this other trend is we know that in the product development space, software is coming, right? Software's all over the space. Any product you can think of just about these days is electromechanical with code, right? So you've got all these different domains in your product development process, and a lot of organizations struggle with that. Having software developers sort of working in sometimes their tools and their models. And I think the thing specifically we want to get to here is when they do their check-in, check-out, it's not check-in, check-out, right? They operate a little differently in terms of how they manage their code and how they manage the life cycle of what they're working on. And that's different from the way traditionally people are doing it with mechanical designs, with electrical designs. And so we have this world that we're getting to that we see in PLM when we try and put it all together in a PLM system, or even with processes, right? If you stop thinking about the software, but the processes people are using, we get challenges, right? We get issues. And what do we see there trend-wise? Is that something in 2025 we're going to see, there's another way to deal with this. There's something different to look at here. I think this is really interesting about what might be coming.
Yes, thank you. Thank you for your, I think you made a great introduction to a very painful process that known by all engineers is checkout, check-in. Because of I believe the history, because everything started with the CAD file management.
Right.
The fundamental process was let me check out and then make a change and then check in. So files were in the middle of this, and CAD files were in the middle of all this. Now, what is coming now and what will be different with complex products that you mentioned? We have electronics, mechanics, software all together. The data is coming from multiple teams that are working not at the same time and obviously cannot be synchronized together. You cannot say to everyone, okay, check out, okay, check in. I mean, this is just doesn't work. So this is one aspect. The second aspect is that different systems behave differently. So you have electronic design system works in one way, you have mechanical system works in another way. Now, let me make it even more complex. We now have a trend of cloud CAD systems that take in some elements of data management and bundle it to the CAD design system. So we have systems like Onshape, we have systems like Fusion 360, or I think it's called Fusion now, Fusion. So we have those systems. Now they managing data, but they managing data that they design and manage. Okay, so this is data. So I have mechanical design. So not
files, right? Being the important part there, right? So they can do something different. They can be creative. And for those who don't know, right, I just want to give this context, Oleg, because I think it's important. What you're saying is some of those CAD systems that are mechanical CAD, and you would think in your mind they operate in the traditional check-in, check-out mode, don't, right? They're operating in more of the software lifecycle mode, right? So that's where things get interesting. So keep going. I just want to make sure our listeners have that context.
That's a very, very good point. Thank you for mentioning this. So now, if I come with this reality of the systems that some of them work differently, some of them are managing files, some of them are managing data already. And then we have software engineers that managing projects differently. And then we have electronics. Now we have all these different elements. So how people can work in terms of life cycle and in terms of changes that will make it in the way so it can be combined together, coordinated together. Mm-hmm. And I will use this word release. I know many companies using this word release. Like, how it can be released together? So the difference is that we need to have a better model for collaboration. So, and to explain what is better model for collaboration, I will use Google spreadsheet. So a Google spreadsheet, think about working with the Excel file and think of working with the Google spreadsheet. Because again, the concept is the same. So if I work with Excel file, I need to check out my file, make a change, return it back, tell Jonathan, now you can check this out, put your changes, return it back. We get 2 revisions. Or 2 versions, whatever people call version or revision. We'll not argue about this. We have 2 revisions.
That's a whole nother topic.
That is another topic for the next podcast. But
the difference between revision and version, I don't think people are watching that one, but okay.
So you and me, Jonathan, in my short scenario, we made 2 revisions.
Yep.
And we made it independently. So if I don't like what you changed, I will make revision 3 and we'll make it again.
Fix it back, yeah.
So a long time ago, I had a software engineer on my team who kept his files always checked out because he said, I don't want anyone to touch my files. That's a separate problem.
Yep.
But
related.
You probably see where I'm coming, or where I'm going with this. Now, think about, so we ideally get in 3 or 2 revisions of the changes of Microsoft Excel file that we made together. Now in Google Spreadsheet, I put the data and you and me can go to this Google Spreadsheet at the same time. You can type whatever you need. I can type whatever I need. We can see it together. And the moment of time you and me agreed that we get to the result that we want to achieve, we can go and create a revision. Google call it version, but it doesn't matter. Create a revision. So we collaborating together. Both of us see this information at the same time. And we only created 1 revision at the moment of time. We agreed about what we want. So that's, in my view, describes the old way and the new way in the change management, in lifecycle and revision control. Now, if we go to old systems like SolidWorks, PDM, Autodesk Vault, the first is still dominant there, and that will never change.
Right.
They will continue to be this way. Now, but if I think about CAD files, let's say I have an engineer using SolidWorks, no PDM. They need to think how to manage those files, but I need to bring information there for lifecycle. If I have someone is writing a code, I need to bring this information. So what we need to create a space that, for the lack of better term, call it workspace, where all engineers or anyone else will be able to go. This is a shared collaborative space where people can make changes. Mm-hmm. The service can capture changes as we making those changes. When I type new description, it's in the history. When you type a new cost, it's in the history. It's all captured together. And then once we are ready to make a revision, or in change management and configuration management, it's called baseline. So when we ready to create a baseline, we save it. So that's the paradigm shift.
That makes sense, right? I mean, that's the thing that people who use tools and use those processes in software today love, right? That ability to just tag and say, look, I'm ready. It's a snapshot of where I am. Like you said, a baseline. That's beautiful.
So what are 3 problems here? So the first problem is that we still have systems that are working differently.
Right.
So we still have 90% of the industry, at least, using file-based design systems, CAD systems. So somehow we need to manage it. We can probably take another podcast to discuss how possible to do it.
One?
But
You think one? You can think you can do that in one?
Okay. So that's the one problem. The files that still exist. So there are some solutions how to do it. Happy to discuss it. So the second thing is that we should be able to create a mechanism that will capture data from multiple systems and create a mechanism of managing of this workspace. Right. The examples of this exist in Onshape. The examples of this exist in OpenBOM. I can bring some other examples, but this is the fundamental shift from how people work. And the third, very painful, we have people.
It's always, we come back to that a lot on this podcast.
Yes.
People are harder than technology.
So those are three things. But this is the fundamental shift. I can tell you from my experience speaking to many people. It takes a little bit over the hump when the people start, when the moment of time they got this point. It's like, yeah, of course. That's the new way to do it, and this is the way the life cycle will be happening. But I see how people that were like 20 years for working with SolidWorks PDM or similar systems, they come into you and saying, "Where is the checkout?"
Right. Yeah.
Where is the checkout? So like, give me this checkout. But I think again, it's the valid statement and it's a valid request. And people that trained in certain way, the psychology is it's absolutely unimaginable thing. So you cannot change people easy. But I think this is what this paradigm shift is between this serial work on the file which is locked and the collaborative work in the shared workspace that's capable to capture changes and to allow to people to get to results in much more efficient way.
And it's funny on that people topic, Jen, you and I had this conversation, and I don't remember what the topic was, right? Because the people piece comes into a lot of our conversations. Really, but we were talking about generational differences here too, right? Like if you talk to our kids, this idea of working on a Google spreadsheet together and how do multiple people do it and not do what you said earlier, Oleg, about like, well, I changed it, he changed it back, she changed it, he changed it back, that kind of thing. The younger generation they've already sorted that out. It's part of how they operate because of the technology they grew up with. Right. Whereas, other folks who are ingrained in that check-in, check-out process and that idea of my data, your data, it's just interesting how all of this, you need the pieces to come together for a trend like that to really take off, right? So I think it's interesting. It's certainly, we're headed in that direction because we have to deal with some tools do it some way, some do it another, but we're having to put them all together because of electromechanical devices with software. But how will we? What will it take, right? Will we all have to get on the page of doing it a certain way? How will we work in hybrid modes? All of that. So I think it's really interesting one. I'm glad we chewed on that one today.
That is actually, I have my hypothesis what will happen. And this is where these two topics are graphs and this topic are connected. Because if this collaborative service that allows you to perform different action. For example, in OpenBOM, it's just the editing of data collaboratively. In some other systems, that's a collaborative design review.
Right.
Take a look, for example, on Collab. And there are some other services. So you see how the graphs are used to bring information seamlessly from other systems. And what is most important, to merge it together. And this is something that technologically not everyone immediately getting to understand, is that when you need to combine, but think about two Excels. If you need to combine two Excels, how you can do it? It's a nightmare, right? Because one Excel has one list of columns and another Excel has another list of columns. So I need somehow to map, right? This is the most interesting enterprise technology, mapping, and then bringing all together. Very painful, no clear outcome. Now, if I create a graph from one Excel and I create a graph from another Excel, to combine them together, I just stack these two records together. I don't need to do anything. Because I know that there is a record of part one with a description X. And I have a record from a part two with something that's called name. And by the way, name and description is the same, but those were defined into different Excels. So now I can put these graphs together I can put, if I will speak a little bit Chinese, in the RDF, there is a semantic definition of same as. I will say name is the same as description. I get a graph that naturally describes both spreadsheets in the natural form. So this collaborative space that we are speaking, that will manage these changes and processes, will be in a uniform way bringing data using graphs from different sources, combining it all together, allowing to graph to perform bill of material editing, and then if needed, return it back if someone wants to keep that in Teamcenter, Windchill, and other systems still. So that's why,
like you said, this is what connects the two, right? This is the solution to the second problem comes back to some of the technology from the first trend, and that's where it all comes together. That's probably, Jen, I'm going to do you a favor here. That's probably a good way of wrapping us up for today.
It absolutely is. So if you want to tie that all together in a nice bow, feel free.
Okay, all right.
It is the holidays. It is the holidays. Tie it in a bow.
I will. I'll put a bow on it, right? So the trends we talked about today and how they connect, right? We talked about how graph technology, graph models, right? Both, right? And Oleg, thank you for kind of differentiating those two. There's the tech, but there's the concept as well. That is where we're going, right? It's where we need to go with a lot of how we represent product data technology. But importantly, it's going to help solve something related to the second trend. So the other trend we mentioned was multidisciplinary products and managing that data. Right now, we're in a couple of different modes, right? So we've got the discrete serial check-in, check-out mode of a lot of electrical and mechanical designs, and then we've got more of the sort of stream mode of software development. And those are tricky to rationalize and to put together. But the way that graph operates and some of the expressiveness that it brings is going to let us do that. It's going to let us do that with data sort of already in place, and then maybe move toward different or more unified modes in the future. But all of this, we can expect to see some of it coming 2025, maybe a little longer. Might not get all the way there, right?
We'll get
Because we got the people piece, yeah. But I think that's what we wanted to talk about today, right? I think that puts a bow on it. It's fun stuff, right? We got a lot to look forward to, a lot of fun things to see in the year ahead.
I agree, and I feel like we'll be back on talking about a few of these topics in greater depth. So
I feel like we could dig into those with a few episodes.
It's amazing. It's amazing to think. I just look on the watch. I mean, how fast time is running.
It's okay. We can have you back. We can always have you back.
This has been good, though, Oleg. Thank you very much for being here to talk about this.
Great conversation, Jonathan, Jen. Amazing to have these conversations together. I hope we get to some degree of understanding. And what I like is the way you summarize it. So getting to these aha moments. Right. It's like not about buzzwords. It's about how we get to the understanding of why is it important and how it can change the way people work already today.
Well, and understanding those two pieces is what enables people to accept change, is understanding why and what they will gain from it. So it is a good place to stop. And we do have to stop. We're well over time. So it was Oleg, you touched on the word conversation. And that is what we promote with our listeners, is we want everyone to be a part of the conversation. So if you have any questions about what we talked about here, or any discussion points, any trends that we didn't touch on, since we went in kind of in deep depth on two rather than, what are all of the trends out there, please reach out and give us your input. We want to hear it, be part of the conversation. And until next year and next time, stay sharp.
Thanks, everybody.
Thank you. Thank you, everyone.
Thank you for being here and listening to this episode of Stay Sharp with Razor Leaf. If you like this podcast, please be sure to hit the like button or subscribe to our podcast on your favorite podcast platform. If you have any questions or would like to leave a comment about our episode, please do so on our social media pages or send us an email to podcast@razorleaf.com. We'd love to hear from you, and we'd like you to be part of the conversation. Please suggest some topics for 2025. Until next time, stay sharp.